In this review, we're going to do multiplying and dividing, adding and subtracting fractions and decimals. We'll start with multiplying fractions, and we'll go from basic to more advanced examples. One of the simplest kinds of multiplying is when you just have two fractions, two proper fractions, like 1/5 times 2/3. And in this, you just multiply the two numerators and the two denominators, the 1 and the 2 times the 5 and the 3. So 1 times 2 would give us 2, and 5 times 3, that's a 3, it's kind of a bad 3, would be 15, and this is in lowest terms already. Another more simple example is 1/2 times 2/5. We could get 2/10 if we just multiplied, but you can also reduce before you multiply by comparing the numbers in the numerator to the numbers in the denominator. In this case, you see a 2 here and here, or 2 goes into both this numerator and this denominator. So we can cross-cancel before you multiply by, it's basically a version of the equal fractions property saying that you can divide the numerator and denominator of a fraction by the same number and get an equal fraction. 2 divided by 2 is 1, and this 2 is divided by 2 is 1. So now when we multiply, we get 1/5, and that's lowest terms. Now let's take a look at a real advanced example, which would be two mixed numbers multiplied. 3.5 times 4 2/5. Here we're going to change both mixed numbers to improper fractions, and the strategy here is 2 times 3 plus 1, which results in 7 halves, and 5 times 4, because 4 has, how many fifths does 4 have in it? Every fifth has 5 fifths, and there's 4 of them, so that makes 20 fifths plus 2 more, makes 22 fifths and 4 2/5. And you can see there is a common factor between the 2 and the 22, but not between the 7 and the 2, and not between the 7 and the 5. So we can divide 2 into this and 2 into this before we multiply, which would give us 11 and 1, and the result is 77 fifths. Every group of 5 fifths makes 1, so we want to find out how many 5s there are in 77 and how many left over. So we know it's not going to go evenly since 77 doesn't end in a 5 or a 0. We'll use short division. There's 1 5 and 7, remainder 2, and 5 goes into 27 5 times, remainder 2, and that remainder would be in the denominator, and it would be fifths. So our answer is 15 2/5, and if you take a look at this, this is about 4, and this is about 4, so we would estimate the answer would be around 16, and 15 2/5 is pretty close to 16. So that's the quick review of multiplying fractions. Next, dividing fractions. If you know a few simple rules or tricks, you know how to multiply fractions, you can easily get division of fractions, because division is the inverse of multiplication. So if we have, let's take one we know. If we did 3/5 divided by 1/5, one way to think about division is repeated subtraction, and you can take 1/5 away from 3/5 3 times, so we already know the answer to this will be 3. Likewise, we could say 3 divided by 1 is 3, and 5 divided by 5 is 1. It's 3/1. But we're going to use the inverse of multiplication rule to get, just know we're going to get 3. We should get 3. We've seen 2 ways we can get 3 already. And up here is the third way to get 3. You can leave the dividend the same. 3/5 is the dividend. 1/5 is the divisor. So we're going to leave 3/5 the same. We're going to do the opposite of dividing, and we're going to do it with the inverse of 1/5. And inverse is just when you flip the 1/5 and make it 5/1. 1/5 and 5/1 are inverses because when you multiply them, you get the number 1. So we're going to make this problem 3/5 times 5/1. And we can reduce by dividing 5 into 5. It's been really weird that all the examples has been this denominator in this position divided by into the numerator in this position, but that doesn't always happen. It could be a common factor between these two numbers or these two terms. It's just kind of worked out with the examples is how it's been. And that we say 3 times 1 is 1. That would be this 3 times 1. That's the 1. It's 3. I think I said it was 1, but it's 3. 3 times 1 is 3, and 1 times 1 is 1, and that equals 3. So we're going to, the process we go through with division is to make it a multiplication problem. If it's, if you have something like this where you can do 3 divided by 1 and 5 divided by 5, you can do division by keeping it division, but that's kind of rare. So let's take a look at a pretty advanced problem, and we'll do 2 1/3 divided by, we'll make a larger number here, so we're going to get a fraction as an answer, 5 1/2. So we're going to make this, we have to change both of these mixed numbers to improper fractions by doing 3 times 2 plus 1 is 7, so this will be 7/3. 2 times 5 plus 1 is 11, so this will be 11/2. And you are better off to just write that before you change division to multiplication. So 7/3 divided by 11/2. Now we'll change it to a multiplication problem. 7/3 times 2 11ths. Whoa, these are all prime numbers. 7, 2, 3, and 11 are all prime. That means you know for sure there can be no reducing before you multiply. So it's going to be 7 times 2, 14. 3 times 11, 33, and that's the answer, 14/33. Knew we were going to get a number less than 1 because you can't subtract 5 a whole time from 2 1/3. 5 1/2 is larger than 2 1/3. So, this is almost like 2 divided by 5, almost like 2/5. So this should be fairly close to 2/5, and of course it's less than a half. 14/33 is less than a half. So this is a very reasonable answer, 14/33. Then we'll move into working with decimals, both multiplying and dividing. We're doing 1 4/10 times 3 as our first example. And we just can multiply this like it's 14 times 3. Just kind of forget the decimal in the beginning. 4 times 3 is 12. Regroup. 3 times 1 plus 1 is 4. And our rule is, as many decimal places as there are in the numbers that we're multiplying, that will equal the number of decimal places in the product, in the answer. 3 is a whole number, it doesn't have any decimal places. 1.4 has one decimal place. It's the number of, that's the digit behind the decimal, to the right of the decimal. Here's our decimal. There's one digit to the right of the decimal, so there'll be one decimal place in the answer, and it will go right in between the 4 and the 2. If this had been 0.14 times 3, we're still going to have a 4 and a 2 in the answer, because we're going to do it like it's 14 times 3, but we're going to have two decimal places in the answer. So we have to go over 1, 2, and put that decimal in. Suppose it had been 0.14 times 0.3. It's still going to have a 4 and a 2 in it. But when we count the decimal places, we have 2 in the top factor and 1 in the bottom factor, and we have to have 1, 2, and what we're going to do here, because we need another one. Have to put that 0 in there. And probably should be putting a 0 here in the 1's place for these two. So let's take a look at one more advanced example that doesn't have a 14 and a 3 in it. 7.1 times 0.3. So we're going to do 3 times 1 is 3, 3 times 7 is 21. Count the decimal places, 1, 2. Count over from behind the 3 and go over 1, 2, and put that decimal in. To understand dividing by decimals, we're going to relate it to fractions and the equal fractions property. We're going to have an understanding here that we will not divide by a decimal number. So we're going to change 3/10 to a whole number And if we change the divisor, we're going to do something to change the dividend so that our answer to 3 divided into whatever results here is the same as 3/10 divided into 18 thousandths. So according to the equal fractions property, now let me back up a little bit. These two problems are the same. This is 3/10 divided into 18 thousandths, and this is 18 thousandths divided by 3/10, same problem. This is written in a way that's something similar to a fraction, and it behaves like a fractions. So the equal fractions property can be applied to this when we write it this way. And it just says that we can multiply both terms of the fraction by the same number, and we're going to choose 10, conveniently 10, because I want to get, I'm going to run out of space here, so I'm just going to bring it down here. I'm going to get, on the bottom, I'm going to get 3, because it's going to slide this decimal over one place. And on the top, move the decimal one place. When I multiply by 10, it's going to result in 0.18. So in the same way, I can do a multiply by 10 with this problem. It'll move the decimal one place, and it'll be a 3. I can move the decimal one place here, I'm multiplying by 10, and it'll be 0.18, or 0.18. And I'm going to show that I did that by this little mark here, and slide this one over the same number of places. Then I'm going to come straight up and put the decimal in. Oops, let me make that a little bit better. A little bit better. So then I will say how many 3's are in 1, and the answer is 0. I must put a 0 above that 1. Then I would say how many 3's are in 18, and the answer is 6. And I have the answer, 0.06. So the idea is convert or change the divisor to a whole number by multiplying by 10 or 100 or 1,000 or some multiple of 10. And that will result in the decimal place moving. If it moves one place here to make a whole number, you have to move it one place in the dividend. If you move it 2 places, you have to move it 2 places. So let's take a look at a more complicated problem. Let's go 0.004 divided into 6.4. So this one I'm going to have to slide this decimal over 1, 2, 3 places. And when I try to move this one over 3, I go 1, and I got to go 2 more. And I have to put zeros in there to hold the place. 1, 2, 3. And I'm going to do this one pretty quickly. We know the decimal will be after this 0 right there. So 4 goes into 6 one time, remainder 2. 4 goes into 24 6 times, remainder 0. 4 goes into 0 0 times, and into 0 0 times. Now, the decimal would go here, big fat decimal, but don't even bother to put it there, because this would be 1,600 and what? Well, nothing. There's no need to put any digits after that, so just don't bother to put that in there. Take a quick look at another a place where you have to annex some zeros in the quotient. If we had something like 0.3 divided into a really small number, like I'm making 0.0006. Now erase that and make a better 6. So we multiply by 10, makes that a 3, multiply this by 10, puts the decimal right here. But the problem here is now we've got, we know that out here above the 6 there's going to be a 2, because 3 goes into 6 2 times. But what about this place value and this place value? You can't just leave them blank. It's not 2/10, it's actually 2,000, so you have to put a 0 in and another 0 here. So your first step is, just review, make a whole number out of the divisor, multiply it by 10, 100, 1,000, move the decimal as far as you need to the right to make it a whole number, move the decimal an equal number of places, bring it straight up. If you have to annex zeros here to hold places, you do it, but you just divide it just like it's 3 into 6. But decimal placement is real important. And then if you're not sure that your answer is right, you can always multiply it and we get 6, and we should have 1, 2, 3, 4 decimal places. There's, 6 is 1 and 2, oops, sorry, 2, 3, 4, decimal, and sure enough, we get what we started with. Oops. 6 ten-thousandths and 6 ten-thousandths. Unlike multiplying and dividing, when you add and subtract, you have to add and subtract things that are the same. You can multiply and divide things that are different, but when you add and subtract, they must be the same thing. So with fractions, that means common denominator. If I'm doing 1/7 plus 2/7, I can just add the 1 and the 2. And sevenths functions like a label. It's like 1 cat plus 2 cats is 3 cats, but it's sevenths, not cats. So we just keep it sevenths. However, if this had been 1/7 plus 2/14, I have to make this, let me make that 3/14. I have to say, I usually would take, to try to find a common denominator, I would say, look at the 14, compare it to 7, count by 14s until you find something 7 will go into, and start with 14. Will 7 go into 14? And sure enough it does, so we know that 14 will work as a common denominator. I'll leave this 3/14. And now I know I can change 7ths to 14ths because 7 goes evenly into 14, and I can do that by multiplying by 2. And whenever I multiply the denominator by, I have to multiply the numerator by. And now I'm set to add. 2 and 3 make 5. Keep the label the same, it's 5/14. So if I had, I mixed number, this is a more advanced problem, but say 5 2/3 plus 4 1/2. And I want you to get in the habit of writing these top to bottom. You can, if you have the same denominator, you can work left to right. That's pretty easy to do. But when you have different denominators, go top to bottom so you can show your work and how you're going to find a common denominator. Also here, I want to make sure that I write the whole number part in a fraction bar and the whole number part 4 in a fraction bar. Now I'm going to be using the strategy of saying, will 2 go into 3? And the answer is no. So I'll try the next multiple of 3. So I'm counting by 3s until I find something that would be in the list of count bys by 2. So I'll try 6 next. 3, 6, 9, etc. But I'm going to try 6, and 2 goes into 6. So that's the one I want. Now we'll say, how do I go from thirds to 6? And that is multiplied by 2. Multiply this by 2, and I get an equal fraction. How do I go from 2 to 6 with multiplication? And the answer is multiplied by 3. I have to multiply the numerator by 3. And now I'm ready to add. 4 and 3 make 7. 5 and 4 make 9. But, you see, there's a problem here because this is an improper fraction. 7/6. 7/6 is equal to, well, let's do that. I have to create a space to work this, but it'll be up here. This is 7 divided by 6. And the answer is 1 and 6/7. 1/7, I'm sorry. Reset 6 and make it a 1. That's where the 1 comes from. Remainder 1. Remainder goes in the numerator, and 6 in the denominator. So this is the same as 9 plus 1 1/6, which is 10 and 1/6. That's 10. We have the same idea when we subtract fractions, that we have to subtract things that are the same. So if we have 4/5 minus 1/5, we're good because fifths, the 5, is already the same denominator. So we're just going to do 4 minus 1 to get the numerator, and 5 is the denominator. But if it was 4/5 minus 5/9, You have to find a common denominator. So we're going to count by 9s until we find something that 5 will go into, which means it has to end in a 0 or a 5. So we try 9, 18, 27, 36, and then finally 45 works. And this is an example of when you could just do 5 times 9, get 45. You can always get a common denominator by multiplying both denominators together, but it's not always the smallest one. In this case, it is. So we're going to use 45 as a common denominator. These are multiplied by 5, multiply the numerator by 5 and you get 25. Multiply by 9 to get 45, and multiply 9 times 4 to get 36. And we can subtract 25 from 36 11 times, and that gives us the answer. If we had mixed numbers here, I'll just do a really simple one. 6 2/3 minus 4 1/3. It's simple because the thirds is a common denominator already. We just subtract the fraction column. 2 minus 1 is 1/3. 2/3 minus 1/3 is 1/3, and 6 minus 4 is 2. However, sometimes you'll get something like, I'll keep the 6, make it 6 1/5. Minus 4 and 1/4. Use a fourth. Now, a fourth happens to be larger than a fifth, so when we try to do 1/5 minus 1/4, we're going to be trying to subtract a larger number from a smaller number. But we know we can do it. We can do this problem because 6 1/5 is larger than 4 1/4. So let's see what happens when we get a common denominator. It'll be more obvious that we have an issue with the subtraction. We can count by 5s until we find something that 4 will go into, and that's going to be 20. So I'm going to slide this over some and use a little more space anyway. So we're going to go to 20ths. And we want to keep these whole numbers in here too. We don't want to lose them. This would be multiplied by 5. So we multiply 1 times 5. That's 5, so it's a bad one. Here we multiply by 4. Multiply 1 times 4. And we see we're trying to do 4 minus 5. Big problem. But not a huge problem because 6 is larger than 4. We can regroup from the 6 and make it a 5, but add the 1 that we regrouped from to the 4/20ths. Remember that 1 is equal to 20/20ths. So when we make this a 5, because we're renaming 1, this 1, we took it away and make it 20/20ths, and we're going to put the 20/20ths right there. We already have 4, so we're going to have 20 more, and it's no coincidence that it's 20 and 4. That's what we have to do to get the new numerator, which is 24. And now we're good because we're trying to do 24 minus 5, which is 19, over 20, and 5 minus 4 is 1. So our answer is 1 19/20ths. Now on to decimals, which are easier than fractions. When you're doing addition and subtraction with decimals, just remember that you can only add and subtract things that are the same. And here, the same means the same place value. So when we do 6.1 plus 5.03 and rewrite it vertically, we make it 6.1. We make sure that when we put the 5 in there, which is in the ones place, it goes right below the 6, which is in the ones place, or you can just think line up the decimal points. And it will be automatically lined up if I put the 5 here and the decimal there. Now with addition, it doesn't matter if you annex zeros, because you see what we're doing here is adding 3, and then there's nothing that appears above the 3. This is the ones place, the tenths place, the hundredths place. So we have 0 tenths and 3 hundredths, but there's not any hundredths in 6.1. It's a good idea to just go ahead and put that in there, that the 0 means not any, so go ahead and put the 0 in there. Again, it won't matter for addition, but you can get really messed up with some subtraction problems if you don't do that. So 3 plus 0 gives us 3, 1 plus 0 is 1, 5 plus 6 is 11, and don't forget to bring the decimal straight down. That's very similar to all the addition problems, so we'll just go on to subtraction, which can be tricky, a little bit trickier than addition in some cases. Now the video is getting kind of long, so I'll just give one example that kind of wraps up all the difficulties in one problem. 18 minus 3.05, you set it up vertically and you write 18. See that the 8 is in the ones place, so you're looking for a decimal here, but you don't see any because you know line up decimals, but maybe you should think ones place, so the 3 has to go below the 8, and then everything else kind of fall into place. 3.05. Mid subtraction. So what's going to happen when you try to do 5 from something up here or 0 from something up here? Be careful. Remember, the idea was it's always a good idea to annex zeros when they don't have an equal number of place values. Again, it doesn't matter in addition, but in this subtraction problem, it would be a big deal because it's not 15.05. That is not the answer to this problem. You must put the decimal in and annex 2 zeros, or you will probably get the wrong answer. Because you know that this becomes 0 minus 5, and here's 0 minus 5, not the same thing as 5 minus 0. So we have to regroup, and this is sort of a long way to do it. And then I'll make a 9 here and a 10 here, but now we're set up to subtract. So we go 10 minus 5 is 5, 9 minus 0 is 0, 7 minus 3 is 4, and 1 minus not any is 1. And the decimal comes straight down. So our answer is 14 and 500ths, but the key was line up the place values. If you don't have a decimal shown, this is a whole number, so you don't see a decimal. This is tens place, ones place. The decimal already separates the ones place decimal point from the tenths place, which would be there. So this would be, it's the same as 18.00. This would be tenths place. You put a 0 in there, it's fine. And you needed 2 of them. So that's a really quick review, and hopefully you're ready to take another retest.